Alright everybody, thank you very much for joining us. Level 1 Part 3 of Key Digital's online training curriculum. Level 1 Part 3 is titled Enhancing the Key Essentials. We discussed the key essentials before. The key essentials, meaning the essential of every AV installation, is having a source and a display, an input and an output, and connecting the two, whether it be via traditional cabling or category cabling in the case of using a Balun device. So how do we enhance the essentials of an AV install? Well, we make it more custom, of course. As you see, you can have multiple sources, multiple displays. Really, as you all know, you can have as many sources and displays as wild as your client's imagination may be. And it's Key Digital's niche to create the pieces in the middle that enable the connectivity of all of these devices in the desired way. So when you may have, for example, cat cable, as we discussed before, as a means of extending your signal from point A to point B, you know now that you'll need a category Balun device. If you have many sources to one display, you will need a switcher, and this is certainly a product category that we're going to be highlighting today. If you have one source and you need to go to many displays, one input, many outputs, is going to require a distribution amplifier. If you have many sources to many displays, then you will need a matrix switcher, where you can have a matrix switcher in the middle, have many sources, many displays connected, and be able to view any of those sources at any time and any combination on any of those displays. And if you have various formats of video types for your various sources, and you need to convert that, format it up front to be one format type to enable a large-scale system like a matrix switcher, for example, then you're going to need a video processor. And of course, what we refer to as traditional cabling with Key Digital, best-in-class HDMI cables, latest features supported, the best speeds, etc., all the way up to 75 feet. You know now that you need the Python series of Key Digital HDMI cables. So what we're going to emphasize here, as I said, is what we have highlighted. The applications where you need to enhance having just point A and point B. You may have many different video sources at that point A with one display at point B, or you may have one source at point A and you might not just have point B. You might have B, C, D, and E all wanting to view that video source. How do you do that? With Key Digital switchers and distribution amplifiers. Starting with switchers, Key Digital offers, under our Phantom series, KD HDSW 2x1, KD HDSW 3x1, KD HDSW 4x1. As we discussed before, the Phantom series is not the first line of HDMI switchers that Key Digital offer. Before, years ago, we had another series of switchers that really gave all the bells and whistles that was really only required in maybe 5 to 10% of applications. What the Phantom series does is enables Key Digital HDMI handshake handling that is not only going to treat HDMI as video and audio, but also recognizing the need for EDID negotiation, HDCP proper handling, at a cost-effective price point. And as it was originally presented to us before Phantom was created, many of our partners in the industry wanted to have Key Digital at the price point that was typically offered by the lower brands, the good brands, the better brands, but not the best brand, like a best-in-class brand such as Key Digital. They wanted Key Digital at the good and better price point, and that's where Phantom came about here. So as we look at the 2x1, 3x1, 4x1, first of all, you notice that 2x1, 3x1, and 4x1 are very common applications. However, in Key Digital's original HDMI switcher offering, there was only 2x1 and 4x1. Again, just emphasizing that value. If you only need 3x1, you don't have to buy a 4x1 with the Phantom series. So you have switchers with 2, 3, or 4 inputs and 1 HDMI output. It's just an HDMI connection. It supports video and audio, of course, on that HDMI connection, and it supports all the resolutions. So whether this is being used for a residential installation, you might have your common standard and high definition 480i, 480p, 720p, 1080i, and 1080p resolutions, or whether this is a computer application where you may have any of your VESA type resolutions all the way up to 1920 by 1200. Phantom series supports those resolutions without any problems. And additionally, Phantom series offers EDID control. They're controllable, these switchers, via IR, via RS-232, and of course via a push button control on the front of the unit. So here's a quick look here, just as a means of giving you a more up-close photo of what you may be working with here, and I'm sure you'll like it. You not only have, for example, in the 4x1, 4 HDMI inputs, 1 HDMI output. You can see above each and every HDMI connection you do have the screw terminals. So if you were to purchase your KD HDMI clip that we covered in Level 1 Part 2 to secure those HDMI connections, you know that that connection is never going to slip out there, even if you yank on that HDMI cable. On the lower right-hand portion of it, on your right-hand side, you do see your control connections. You see a small little dip switch there that's just to the left of the RS-232 port, the DB9. That is our operation mode switch. And it should be noted that with all Key Digital products, normal mode is what you're always going to be in, unless you're updating the firmware to your product, in which case a lot of products now have it labeled as program mode. Other products that are previously released for Key Digital may have referred to that mode as Mode A, but whether it says program mode or Mode A, it's only for firmware updates. RS-232 for control, and of course it's bidirectional, meaning you can get status responses, etc. from the Phantom series HDMI switchers. You have 2 ports for IR in the back there as well. A serial IR port, which is a 3.5mm connection used for a hardwired IR connection from your control system. Also included in this is a IR receiver, in case this switcher of yours is going to be located inside of some AV furniture perhaps, and you just want to use line of sight IR. We have an AV receiver that's included. Additionally, you see right there a small circular opening that is labeled IR. That is just as the IR sensor on the front of the unit, and a second IR sensor and a second IR receiver built inside the unit, except for there's no plastic covering. So typically AV installers, custom installers, or dealers and contractors utilize that when they put an IR emitter over the product to control it via IR. Using that without the plastic cover just makes it a little bit more robust. And to your left-hand side, you see the EDID control portion of the product. EDID control is very important and just furthers the value added by the Phantom series, where in fact the original Key Digital switchers that again offered all these bells and whistles with external audio connections, LEDs that did a song and dance for you, etc., were very good, but they had no handshake negotiation in the switchers. Only our early DAs had it. Here, with our switchers, you also have the means of controlling the handshake and manipulating the handshake as the installer for the system, where a lot of other switchers out there in the marketplace just rely on transparency. Essentially an A-B switch to paint a picture of a transparency in the middle, essentially just pretending that we're not here, and instead just creating a channel for whichever of the 4 sources is actively selected to be directly connected to the display. Well, sometimes, as we know in the HDMI world, due to a very complicated and very long string of EDID information, sometimes there are misreads. Sometimes it's not as simple as just 4 sources into a switcher into the display, and instead you might want to have a little more control over that handshake, and certainly that's something we're going to discuss more along this presentation. What is EDID? Well, EDID is a part of every HDMI connection. In fact, it actually originated with the VGA connection, the HD15 connection between the monitor and the computer. Essentially what it is, every display has an EDID file. It is a list of preferences, if you will, or compatibilities, if you will, and it is a very important part of the data transmission of an HDMI connection. So imagine a one-to-one scenario. A one-to-one scenario where you have a display and a source. That, say for example at my house, my display turns on and it tells its source, hey, I'm 1080p capable. I'm not 3D capable, so when you're at that 3D channel, you cannot output that 3D content. Or maybe it says to the Blu-ray player, display to a Blu-ray, I'm 1080i capable, I'm not a 1080p display. This is all done automatically in an HDMI connection, you see. Whereas in the past, the installer certainly had more control in the analog world over what resolution the source device was outputting at all times. In the HDMI world, essentially it has become automated, where the display again sends that EDID file to the source. The EDID file complies, outputting 1080i, knowing that the display itself is not capable of 1080p. That's assuming that a nice solid read is established. So again, EDID stands for Extended Display Identification Data. It's a part of every HDMI connection. In fact, here at Key Digital, there is a formula we like to discuss here all the time, which is HDMI equals TMDS plus EDID plus HDCP. And you might be thinking, Jonathan, I don't even have my pen out. I better get it now. Give me that formula one more time and tell me what it means. HDMI equals TMDS, which is the video and audio portion of an HDMI signal, plus EDID, the identification data of the display, plus HDCP. And of course, if your source is not HDCP, then that's really not going to be a portion of the equation that we have to worry about. But in any case, you'll always have the EDID, the information that actually kind of follows flows in reverse, where the video and audio, of course, originates at the source, goes to the display. The EDID comes from the display back to the source, telling it, here's what I'd like you to output here because this is what I'm compatible with. As I mentioned earlier, this was actually originated in the VGA world, in the computer world. It was actually a standard that, as we see in the bullet point, was defined by VESA. It includes not only video resolutions and audio resolutions, but a lot of very important information, aspect ratios, color, spacing, and that sort of thing, etc. Now, in the VGA world, though, it was not as strict. You essentially, if the monitor didn't relay any EDID information, and if you take a look at that VGA pinout, that's on the DDC channel is what it's called, where that data is was translated or was given from the display to the source. In the VGA world, the computer itself, if it didn't receive an EDID file, it would typically just default and output something rather generic. In the HDMI world, of course, because of security and copyright and protection of this high definition content, it wants to know the EDID file. Now, what happens if it doesn't receive that EDID file really depends upon the source. It may not output anything whatsoever, or it may still output something and you'll be able to tell that it's not right. For example, usually a neon green screen, you may have your picture and everything, but a neon green image is typical of an EDID misread. And why is there misreads? Well, as we were just mentioning last slide, HDMI, an EDID file, it goes way beyond video resolutions and audio formats and that sort of thing. It is very extensive. Therefore, the chances for error are much greater than, say, in the VGA world where it wasn't as extensive. So this is why it's important to have the control for a portion of it. If you think about the case of a switcher, it's again, transparency could work in a simple switching application where you have many sources, say 2, 3, 4 plus sources to just one display. It could work. However, it is nice to have this EDID control as a safety net, especially as your system becomes more elaborate. So what are the EDID control possibilities we have for the Phantom Series HDMI switchers? Well, you use those red dip switches that we showed you there earlier. There's 3 dip switches, and it allows you to make about 7 or so different possibilities of combinations for those dip switches. All in the down position is the default, and that's meaning the box, the product straight out of the box is all set to the down, down, down position. That is a bypass. That is a transparency. Again, the display's EDID file as it is relayed directly to the source. Okay. Other than that, though, we have a 1080i with 2-channel audio EDID format. We have a 1080i with HDMI 1.3 audio format, so you get into your Dolby Digital 5.1 and that sort of thing, and beyond. Your high definition audio formats. For 011, meaning down, up, up, you have 1080p with 2-channel audio. Or the 100 setting is a 3D handshake with 2-channel audio. Additionally, we have 3D with HD audio formats of the HDMI 1.3 features. And again, any other combination that you can make is going to revert back to that bypass where essentially just whatever source is selected is going to get that handshake directly from the display itself, assuming that your piece of extension in the middle, whether it's an HDMI cable or a balun, there's no misreads there, and it is successfully extending that information. So it's somewhat important in the switchers, but again, not so much important in the switchers to have EDID. It does come in handy though every once in a while. We've seen it many times here at Key Digital because switchers, it's not always just going to be multiple sources into the switcher to the display. You know that a switcher is typically part of a larger system. Now where it becomes especially important is in the case of a distribution amplifier. And so, as a recap, a distribution amplifier is when you have one source to many display. Okay? So let's look at the product first, and then we'll talk about the EDID. Key Digital, under the Phantom series, has our distribution amplifiers, HDDA 1x2, HDDA 1x3, HDDA 1x4, and finally HDDA 1x8. 1x8, very large. It's perfect for your large-scale retail applications, as we were discussing earlier, or your large-scale HDMI digital signage, truly digital signage applications where you have 8, 16, 24 plus displays all viewing one source. So as we look at the 1x2, 1x3, 1x4, and 1x8 Phantom Series distribution amplifier, you notice it looks exactly like the switchers, the 2x1, 3x1, and 4x1. They're all half rack width products. The 1x8 is a full rack width, okay? They all include the rack ears. In fact, the half rack width products, whether it's a switcher or the DA, includes a half rack length. So that is worth mentioning here for those of you mapping out your racks as we go over the training. So you have one source, you have multiple displays, 2, 3, 4, 8 displays. Again, supporting all of your video and audio resolutions and formats, whether it be SD, HD formats, or your VESA formats up to 1920 by 1200. Also supporting 4K by 2K resolution as well. You can cascade these, and that's going to be something that we talk about. Again, like I said, digital signage retail applications, usually 8 displays is not enough, and you may need to go way larger than that. And we can do that here at Key Digital. So let's talk about the EDID control in the Phantom series distribution amplifiers. You may recognize this as being quite similar to the EDID library of the switcher. So again, this is a library that's internal of the key digital piece of gear. But additionally, you have other options that we'll go over here, allowing you to take a direct copy of the display and relay it to the source, never allowing for direct communication, but instead taking a copy, adding it to our library essentially, and then relaying it to the source. So out of the box, what's going to happen with the EDID control portion of key digital HDMI distribution amplifiers? And this is a fantastic technology here. This is something that's been happening for about 5+ years, 5 to 6 years from today's date, with the introduction of our first ever HDMI distribution amplifier, the HDMI 2x4P. We had this default mode. What does that mean? Well, imagine you got a 1x4, you have a 1x4 HDMI distribution system going on using a key digital HDMI distribution amplifier. What key digital HDDA 1x2, 1x3, 1x4, 1x8 products are able to do out of the box is you power on your displays, and this is typical of your initial setup. Key digital will pull each and every one of those display devices or output devices that are connected. It pulls those devices for their EDID information, just as if it were a one-to-one scenario, except for key digital HDMI distribution amplifier is the source. So we pull each and every one of those display devices that are connected or output devices that are connected. Again, AV receivers are common, video codecs are very common, of course, video processors, video wall scalers, etc. All very common output devices, and we pull them all for their EDID information. And as we discussed, EDID, there are many categories. It's a very extensive list, and very quickly, a blink of an eye, the processing inside of the key digital HDMI distribution amplifier is able to create an EDID file that is actually the highest common denominator across the EDID spectrum of all the display devices that are connected. We create an EDID file of the highest common denominator. I call it the highest common denominator, not the lowest. Why? Because, say for example, all of these display devices will support 480i, standard definition, right? Now, we don't give the handshake to the source that is 480i. Say, for example, in a 1x4 distribution amplifier case, maybe you have some 1080i's and some 1080p's. 1080p is not the highest common denominator, yet 1080i capability is the highest common denominator. So as far as video resolution is concerned, that's going to be in our EDID file. So the highest common denominator is the out-of-the-box setup for the Phantom series HDMI distribution amps. There's also 001, down, down, up, which is the first detected output. Now, this is not output 1. This doesn't mean whatever's on output 1 is going to determine the handshake. It's the first detected. So meaning you power up your system, and whichever device provides its EDID information first is we're going to work with that EDID file and relay it to the source. So this is a very good installation method that, to perhaps utilize some power sequencing. If you have multiple display devices connected, you always want to power up the display first, which you'd like to take the EDID file from. And again, we pull it, we store it internally in our device, and then we relay it to the source. Just like the HDMI switchers, we have also the generic library that just every source knows and loves and is able to run with, where we have files that we've created here in our laboratory, where essentially we have Noah's Ark of AV equipment in the Key Digital Labs, and we've created the most generic files, for example, 1080i with 2-channel audio, the down, up, down configuration of the dip switches, 1080i with HD audio, down, up, up, 3D video with 2-channel audio, 3D video with your high-def audio formats, 1080p with 2-channel audio, and 1080p with high-def audio formats. Okay, so that's a way to go from our library. And really it's just going to vary by your installation here as to which one you're going to want to use, but just have an understanding of what EDID is really is going to prepare you for that. So let's look at some typical scenarios here just to ensure that you do have an understanding when you go out in the field here what kind of EDID selection you'd like to use. So here's a scenario where we have 3 devices that are connected. You have an AV receiver that supports 3D video and HD audio formats, of course. You have a flat panel display that supports 1080i video and 2-channel stereo. Of course, all your displays are really only going to be able to give you 2-channel audio after all. Now, there are some displays in the marketplace now, and this is very nice, that actually have support for Dolby Digital audio. Typically, it is limited to about 5.1 channels of audio, though, versus 7.1. And they'll be able to decode that audio and of course, display to you two channels of audio on the television, after all. And you have a projector that's 3D and supports 2 channels of audio. So if we were to do the out-of-the-box settings, the down-down-down dip switch configuration for the HDDA product in the middle, what would happen is we would pull all of the devices connected and we create the highest common denominator here. We pull all 3 devices for their handshake. We create a down mix, as we could call it, a default here that is the highest common denominator, and then that's created internally in the Key Digital product and Key Digital software, and then relayed to the source. Again, we never allow for direct communication between display and source. There's always going to be Key Digital in the middle to act as a buffer. So let's take a look at another example where we actually have the same output devices connected, and instead we switch it over to down, down, up. What happens then when we take the EDID of the first detected output? Well, you're going to have these 3 devices connected, okay? Now let's say, for example, we follow the blue line and the flat panel display is the device that powers up first. And typically that's going to be the case if you were to power these all up at the same time. Projectors are typically rather slow to show you picture and slow in their boot up process, as you know, and typically the EDID is not immediately given to the source. A AV receiver perhaps can also be a little slower than, say, just a flat panel display on the wall, where that's usually the quickest device out of this sort of scenario to provide its handshake. So we use the blue line here, and we gather that at Key Digital, we store it, we internally relay it then to our input chip, where your satellite or cable set-top box is connected. And now that set-top box is outputting 1080i video and 2-channel audio. And you say, well, that's kind of silly. I want to utilize the high-def audio formats when I'm using, since I'm listening through my AV receiver here. How do we enable that, even though I'm watching on the display on the wall, not on the projector right now? Well, it's very simple. Either your power sequencing of your AV receiver, make sure that's the device to come up, give it maybe 10-20 seconds, then power up your display. Or you just go from one of our default libraries here, where this is generated internally, where you're going to have, you can choose, for example, if you want to view television on the display itself versus on the AV receiver. You can do 1080i with HD audio formats, the down, up configuration. You select that, and then the satellite receiver is, or your source device complies with it. So typically it's just a matter of understanding the capabilities of all your displays connected, and then choosing the proper setting. As you can see, Key Digital offers a lot of flexibility, not only as far as advanced technologies creating an EDID file internally, but also a lot of flexibility to ensure if you want to cater specifically to one output versus the others, or anything really to ensure that this is a working HDMI system. These could be safety nets, or this internal library could be what you use each and every time, because again, they're very generic, and all the displays out there are typically able to work with those without any issues. So now that we have this handshaking really down pat at Key Digital, and again, we've always had EDID control since our very first HDMI distribution amplifier. What kind of systems can you actually make with it? Well, at Key Digital, we instruct you to stay within 3 layers of HDMI connectivity, but you can make some very large-scale systems. In our original HDMI distribution amplifiers, it was only one. It was a 2-in, 4-out system, or a product, as I said before, the HDMI 2x4P. It was a switcher / DA. It was not a matrix. It had 2 sources, 4 outs. Whichever of the 2 sources were active is what's active on, or was selected is what's going to be active on all 4 displays. And we have a number of retailers across the country doing their showrooms with those products, who had to really invest a lot of money because it's a smaller product and you're using many of them. However, now with the 1x8, you can enable some very large-scale systems. We suggest you stay within 3 layers of HDMI connectivity because, not because of handshaking problems, as you see, we've got that down, but because of any potential jitter that could be accumulated in data loss over each leg of the system. But using our 1x8, you can see 8 cubed here, as we mentioned in level 1.1. 8 cubed now, I know the math for sure. 512 displays. You start with a HDMI, HDCP compliant source at the front end, no problem. It feeds the HDDA 1x8 at the head end. Each of its 8 outputs are connected to a second layer of 1x8s. Each of their 8 outputs feed the 3rd layer of 1x8s. And all of this is accomplished with 1 key from the source. And that's really become a significant marketing slogan here at Key Digital, guaranteeing HDMI reliability where others cannot. With us, that HDMI, HDCP source at the head end only is utilizing 1 key at any given time, so there's no need to worry about how many keys does your source have. As you can see, we can do some very large configurations. And here's a look behind the scenes at one of them that we mentioned to you earlier with the Flanders store, where they had their HDMI source going to the 1x8, and this is in their equipment room. Each of the 1x8 outputs fed a transmit balun, the KD Cat HDX transmit balun. In fact, dual Cat 5, as you can see there. Which then we created output groups. Since it was a retail application, they have walls with maybe up to 8. Some walls with maybe beyond 8 where we have multiple VAs. And this is really the most cost-effective way of doing this system, because when you have the 1x8 located at the output group, now you can use some relatively short-run HDMI cables to each display versus going to a balun with each and every display, and that can really rack up the cost of your system. So here you can see, just as we showed you earlier, the end result, a 100% HDMI showroom. Now your sales floor is able to practice what they preach and sell HDMI and have a store with an HDMI infrastructure versus some crummy analog distribution or coaxial distribution system with the quality that's just not up to par and really able to emphasize the quality of the picture that these displays nowadays are able to give you. It's fully 3D ready, of course, since it's all Key Digital hardware and cabling, and it's just, you know, this system here was over 60 displays. As you saw, we've done systems well over 100 displays and beyond as well. So if you'd like to rack mount multiple phantoms, if you're building a large HDMI system like we just showed you there, how do you do that in a way that's cost effective and space efficient? Well, as we discussed, each Phantom series HDDA 1x2, 1x3, 1x4, HDSW 2x1, 3x1, 4x1, all of the half rack width products include a half rack blank. But if you're doing multiple of these in a rack and you'd like them to be side by side so as not to be missing or to be wasting any rack space, you could do that with the KD BKTHF, as in bracket half. It is a rack mount coupler, if you will, enabling side-by-side rack installation and conserving rack space. It works with all the Key Digital half rack width products. You see a list of the products here. It is not included. It is not included with the products, okay, with the Phantom products. So this is an accessory that you can purchase in addition to your key digital Phantom series switchers, Phantom series distribution amplifiers, our KD VP1250 video processor, and of the Compass control lineup, the master controller KD MC2500 also is a half rack width product. So also under the Phantom series, a product that we discussed in brief before, discussing the reclocking portion of the HDDA and how it repairs that HDMI signal and restores data that may be lost and may be very close to that cliff point where you're not going to have any image whatsoever when you connect it. We look at the Phantom series HDDA 1x1. Now this, as all the other Phantom series products, has EDID control built in, and it makes it very important. This product does not utilize a dip switch as the HDDA and HDSW products do. This product instead uses a rotary. Why? Because there's a more limited amount of options utilizing the dip switches versus using this rotary that has 10 different click positions. Using a Phillips head screwdriver, you'll be able to select either 0 through 9. 0 is the EDID of the connected display. And you see we even open up this EDID library here that's internally in the product to relay to the source if you'd like it to even be a DVI VESA type resolution such as 1280 by 1024 or 1920 by 1200. We have that now as well. So this is very important because you we talked about one of the epitome application where this HDDA 1x1 is installed, the AV receivers, and you may have multiple sources going into an AV receiver, and then you may have, like the scenario we painted earlier, kind of a daytime, nighttime setup in the home theater room where you have a flat panel on the wall for daytime viewing and a projector that comes down for nighttime viewing where you're viewing on the screen. What do you do then? You can't rely on the main and the sub outputs of the HDMI outputs of the AV receiver. Instead, you may want to have a piece like this in the middle where we can tell that AV receiver, hey, we're always going to output 1080p here with 2-channel audio out of the AV receiver's outputs in case they want to utilize the display's audio capabilities. Or 1080p with HD audio is fine because we're always using the AV receiver for its capabilities. So this is very handy. Additionally, this is commonly inserted in any application where you have a computer with HDMI output going in to feed a system here, maybe a switching or distribution system or a matrix system, because computers generally are a little slower to respond to handshake negotiation, so you want to leave a nice constant EDID file there, EDID read for the source, in this case the laptop or the desktop PC to receive, because frankly we've seen many times where a Blu-ray player, a set-top box for example, as soon as you switch that handshake setting on the key digital, it complies with it within a matter of seconds. Computers, on the other hand, depending on how secure they want to be, may not comply until you give it a restart, and that's not a very desirable thing to happen. So it's very good, not only for the EDID control, but also the reclocking as we discussed in section 1.2. This piece is just the piece that every installer has at least one in their van that has used it before because they understand the value. It's at a very cost-effective price point, so I'm going to say it again. Go check out your your local Key Digital representative or channel of obtaining our products, and you'll be surprised that you can have this HDMI fixer in your hands, or perhaps even on every installation, depending on the budgetary concerns, and know that you have this just in case you confront any of these obstacles that poor EDID reading, etc. may throw your direction. So now we talked about HDMI switchers, we talked about HDMI distribution amplifiers, we talked about the HDMI booster or buffer, the HDDA 1x1. What about the analog video systems where you may have a source going to multiple displays, where you have churches, retail applications, digital signage, etc., that may not be at the HDMI level yet because of price points or because of existing infrastructure and that sort of thing. Key Digital has an amazing distribution amplifier that is really utilizes and takes advantage of the most common media found today, again, category cabling. That is Cat 5, Cat E, 5E, Cat 6 cabling can be utilized with our KD Cat DA 4TX. So as the nomenclature implies, it's a distribution amplifier, meaning one source to many displays, with each output not having a local video connection, but instead having a category cable connection, an RJ45 connection. And this, I think, is just a huge savings in a huge headache reliever when you consider most of your applications are going to use cat cable anyways. Why have that balun necessary, that transmit balun necessary in the rack for each and every display? Instead, just plug in the RJ45 into the one of the 4 output ports of the Cat DA 4TX, and you'll be able to connect your displays. On the other end of that Cat 5, Cat 5E, or Cat 6 cable, unshielded or shielded, we should mention, is the KD-CBA-RX, which we discussed in our last section. So we're going to take a little further look at that here now. It is a VGA connection on the Cat DA 4TX and on the CBA-RX, but it supports either component or VGA. So just because it's VGA connection doesn't mean it's limited only VGA applications. It's very versatile, and it includes a VGA to 3-wire breakout cable for the VGA connections there. So that if you're going in component, you go out component, and you know that that's also included with the KD-CBA-RX. So what you see here with the Cat DA, on the right hand side you see your VGA connection, your HD15 connection that is a male port, and beside it you have a 3.5mm plug for your audio, stereo or mono. To your left, you have a local, which is the throughput, if you will. It's a pass-through, perfect for connecting to a local monitor that perhaps is for viewing at the production booth at the church, or perhaps you have a display, a 5th display, so really this connects you to 5 displays, up to 5 displays, that is within closer proximity and doesn't require the Cat cable. It's not a problem. And it's also used for cascading. So that you may say, Jonathan, this sounds like a great product, but we have more than four displays as a destination here. Not to worry. Using that local throughput there, you're able to go from one to the next, to the next, to the next. We say stick within 8 or less cascaded layers, if you will. So that enables systems up to 32 displays, and certainly if you need to go larger than that, we could do it. Just give Key Digital a call or reach out to the system design group that we gave you their contact info earlier in level 1, part 1. So each CBA-RX balun is sold a la carte. You buy the Cat DA 4TX, you pick up 1 CBA-RX per display that needs to be connected. And let's take a look at a common application here where the Cat DA is utilized. You have the VGA output of a computer plus left and right. You have a video mixer that's located there at your, again, your production booth, for example, in the church, utilizing the audio and video throughputs. And you have your 4 displays, whether they be flat panel, whether they be projectors, whether they be video codecs, etc. AV receivers, does not matter, connected with a KD-CBA-RX. And you're going to get video up to 1,000 feet, as we discussed in level 1, part 2, because it is a KD-CBA-RX. Now, how do you get that 1,000 feet of video with high picture quality here? We mentioned the cable equalization adjustment screw and the video gain adjustment screw. Now, this is something that comes in handy for all of the KD-CBA-RX pairings. So CBA-RX, we have for one-to-one applications, we sell the SKU of the transmit plus receive for KD Cat CBA, so you can't forget about that. or we sell the receive by itself to marry in with this CAT DA4TX, or to marry in also with our analog matrix KD MSW CAT 8x8 that we'll introduce you to later in this training curriculum, where this is also the receive balun there. So even if you start with the DA and upgrade to a matrix, knowing that they're going to introduce more sources down the line, that's of course possible without having to overhaul the receive balun portion of the installation as well. So when we talk about making these video and audio or the video adjustments, let's briefly just describe it to you, because sometimes people call and they say, oh, I messed with the screw a little bit here, but it's really, I'm still experiencing symptoms X, Y, and Z. First thing you want to do really is start with, in my opinion, you start with that video gain adjustment screw. The video gain screw is can be called a brightness adjustment, but really it's the gain level. So it's not only going to adjust your brightness, but also if you're going a very long distance, for example, and you don't have quite enough gain, you turn that clockwise, boosting that gain level, and now your display, of course, depending on how the display responds under, and it's going to behave differently by manufacturer. Now your display senses the signal there, and voila, you have picture. Now keep in mind that this adjustment screw that we show the picture of, when it's straight vertical, you will fill a click position. So when your line's at 12 and 6 o'clock, you'll fill a click position, and that click position is representative of approximately 500-foot run at 1024 by 768 or 720p resolution. So that's a fairly long run. I think that more often than not, a lot of applications are not 500 feet. They might be under 500 feet, might be the highest end of that spectrum. So typically you may have to slowly turn that video gain screw counterclockwise to lay off a little bit until you see that image and until you have a nice brightness level. And once you maintain that proper video gain setting, you proceed to your cable equalization screw as we discussed here. This is, let's see here, without the proper cable equalization, you may see some artifacts on the screen. You may see some skewering of your image. Have no fear, the cable equalization screw can solve those problems, and really it's just a part of every install with the CBA-RX balun. Again, just going to take you a minute or two with a flathead screwdriver. Again, has a click position on the EQ screw as well that is representative of about 500 feet, a 500-foot installation extension at 1024 by 768 or 720p resolution. And of course, these distances vary, by cable quality, environmental factors, etc. So if you have a run that's under 500 feet, we'll use that example again. Very slowly turn that screw counterclockwise direction until you will notice those artifacts disappear. You will notice that the picture looks very good. It also acts as a sort of skew adjustment. As we discussed earlier in section 1, part 2, not a full skew adjustment with individual control over the red, the green, and the blue coloring, but instead moving the sync to line up with the color. So really a one-channel skew adjustment versus a three-channel skew adjustment still offers a big benefit over a lot of other VGA baluns in the marketplace without having to step up to a skew compensation balun or skew compensation cabling. And so any kind of ghosting of your image is also corrected with that cable EQ adjustment screw. So artifacts, ghosting, etc., and you'll clock it in, just again take you a minute or two, and then you'll want to observe it for approximately 5 to 10 minutes, maybe leave that display on throughout the rest of your installation, just to see if you, throughout the day, if you see any kind of artifacts come back up on the screen or anything like that, and that might mean you just need to move it a hair in the appropriate direction. Following those installation tips is really going to give you fantastic picture quality, again, up to 1,000 feet. So again, thank you for viewing. This has been Level 1, Part 3, where we enhance the key essentials Again, meaning that you have the essential of every AV installation is having an input and an output device. We enhance that by enabling systems with multiple sources to one display using the Phantom Series HDMI switcher. We discussed the EDID and the handshaking options for the HDMI switchers. We enhance the essentials by going beyond a one-to-one and offering one source to many displays with the Phantom Series HDMI switchers. Distribution amps rather, excuse me, and we discussed their EDID options, and you can see now how very important it is to have handshaking capability and something that takes responsibility for the keys, the handshaking, etc. HDCP versus pointing fingers in any direction and pointing to limitations of a source or display device as some competition does. We built some large-scale HDMI systems, showed you the guideline to stay within to build those sorts of systems, and of course we always suggest you reach out to the System Design Group, sdg@keydigital.com. We discussed the EDID control portion of the HDDA 1x1. We looked a little more at that and expressed exactly why that's a very important piece that perhaps can be useful on every HDMI installation. And then we took the one-to-many distribution amplifier product category and introduced you to our analog solution for that with the Fat Cat series KD Cat DA 4TX with the KD CVA RX, and even discussed installing the CVA RX and some of the pairings that CVA RX enables. Next will be level 2. So we've now completed level 1, where we appreciate you all for taking the time to learn about it and to be introduced to the brand in level 1 part 1, in our resources and our offerings that we present to all of our partners, to be introduced to custom AV in its most essential and basic form with an input and an output, a source and a display, and then took you to the simple switching applications and a simple distribution amplifier application. Next, we're going to build some full circle systems in the analog world. Again, this has been Level 1 Part 3. You've now concluded Level 1. Congratulations, and thank you very much for your time.